Energy equals 4200 times 2 equals 8400, so the liquid heated up fast. If you write this exact sentence in your Cambridge IGCSE physics exam, you are bleeding marks. And here's the hidden pattern. Thousands of students make this exact mistake every single year. Today, we're performing a surgical fix on your exam strategy to stop this from happening to you.
You see, spending hours just memorizing formulas, it's a trap. What you think the examiner wants is just you knowing the math. But ordinary revision completely fails because it ignores how the mark scheme actually works. What the examiner is actively hunting for are correct units, exact scientific wording, and absolutely zero early rounding. If you don't give them this specific combination, you lose those final marks, and suddenly your grade boundary is at serious risk.
Let's actually look at the syllabus itself, specifically Section 5, Thermal Effects. It covers a lot of ground, from moving particles to specific heat capacity and latent heat. And it's these last two where we see the same fatal pattern. You might totally understand conceptually that it takes energy to change a substance's temperature or state. But the second you're asked to calculate or describe it on paper, that mark scheme turns into an absolute minefield.
So we need a totally new approach. We call this the surgical fix framework, and it turns passive revision into an active mark-extracting machine. It takes just 4 steps. First, the concept, pinpointing the exact physics principle involved. Second, evidence or data, pulling the precise numbers they gave you in the prompt. Third, scientific reasoning, actually connecting your data back to the concept. And finally, examiner wording, using the exact vocabulary Cambridge demands. No slang, no guesses.
Let's put this framework to the test right now. I'm going to show you a completely typical student answer for a specific heat capacity question. I want you to literally pause and see if you can spot the fatal errors before I point them out. This is a high-stakes moment. Look really closely at both the numbers and the words. Are you ready?
All right, here's our patient on the operating table. The student wrote, the energy is 4200 times 2. I got 8400, so the liquid heated up fast. I mean, it looks like they tried to use the specific heat capacity formula, right? They substituted some numbers, but structurally, this is an absolute mess. What's missing here? What's too vague? What is fundamentally broken about how this is presented?
Let's run the autopsy on this. First, massive mistake, missing units. They wrote 8400, but 8400 what? Joules? Kilojoules? Leaving units out costs you the final accuracy mark every single time. Second, heated up fast is way too vague. It completely ignores the command word, which probably asks them to explain using actual physics terms. Third, wrong variables. There's no mass or change in temperature clearly stated in their working. They literally just smashed 2 numbers together, which shows the examiner zero practical understanding of the underlying equation.
In a moment, I'll show you the examiner clue that changes the answer completely, but first, you need the framework that makes that clue obvious. Because before we fix the math, we absolutely have to fix the wording of that disastrous answer we just looked at.
Here is the cure. On the left is that flawed answer we just ripped apart. But on the right, look at this top band Cambridge-approved response. See the difference? The top answer explicitly lists the substituted values right next to their variables. It nails the correct units, joules per kilogram degree Celsius. And instead of some vague, heated-up, fast nonsense, it uses proper scientific reasoning. It explicitly states that a lower specific heat capacity means it requires less thermal energy to raise the temperature. This is how you extract every single mark.
Breaking down the anatomy of that perfect answer, here is how you lock in those method marks. You absolutely must hit these 4 criteria. Number 1, correct physics terminology. Number 2, show your substituted values so the examiner knows exactly what numbers you're feeding into the equation. Number 3, clearly state your relevant equations before doing any math. And number 4, command word fulfillment. If they say calculate, give a number. If they say explain, you better give the scientific reason.
But thermal physics isn't just about plugging numbers into equations, is it? We have to look at the practical side too. What happens when you're hit with data analysis and practical investigations, especially regarding cooling curves? This tests your actual experimental skills, and honestly, it opens up an entirely new set of traps where students lose easy marks.
Here are the most common practical pitfalls we see straight from the examiner reports. First up, graph axis errors. Are you actually plotting temperature on the y-axis and time on the x-axis and using more than half the grid? Second, weak practical improvements. Writing "be more careful" is going to get you 0 marks. You need specifics like add a lid and insulation to the beaker to reduce thermal energy transfer. And third, writing conclusions that aren't even supported by the data. Your conclusion has to directly reference the actual numbers in the table they gave you, not just the general physics theory you memorized. Which brings us to your final exam discharge checklist. And this solves that massive early rounding trap I warned you about earlier. The hidden examiner clue is this. If you round your numbers too early during a multi-step specific heat or latent heat calculation, your final answer is going to be mathematically wrong by Cambridge standards. You have to keep the full values in your calculator and only round at the very end. Plus, always do a reality check. Is your final answer actually reasonable? If your specific heat capacity for water comes out to 4.2, instead of 4,200, you dropped a kilo somewhere. Always verify your units and your graph scales.
So, I'll leave you with this. Are your answers just factually correct in your head, or are they engineered on paper to extract every single mark from the Cambridge scheme? Knowing the physics is only step 1, executing it perfectly under pressure is step 2, and that's exactly the problem we need to solve next. Now that you have this framework, you need to apply it against the clock. The pattern library continues in our next explainer on the timed answer writing system, which is your mandatory next step to lock this in. Subscribe to our YouTube channel Ace the Exams at Ace the Exams IGCSE to excel in your Cambridge examinations. Click the explainer on your screen right now, and let's get your timing perfected.